All right, now that we're done with learning how to factor quadratic functions, now we're going to learn how to solve them. All right, so there's two basic ways to solve a quadratic function: graphing it and algebraic. Well, we've already done graphing and we have gotten into algebraic. Graphing, quadratics have exactly three possibilities for their number of solutions. They're either going to have two solutions, exactly one solution, or no real solutions whatsoever. So what we're going to do with these is we're going to see how many solutions it has. We're going to figure out exactly what those solutions are. So if it has two solutions, it touches in two places. If it has one solution, it touches in exactly one place. What I'm saying is it touches the x-axis in either two places, the vertex is on the x-axis touching it in exactly one place, or there are no real solutions where the graph actually never touches the x-axis whatsoever. Alright, so to solve a quadratic graphically, you graph it and you see where it crosses the x-axis. Real straightforward. Algebraically, there's several different methods. So first one is method one. Factor and set each factor equal to 0. So this is the same stuff we've been doing now for a week. You factor your quadratic. It's already set equal to 0 for you if you're solving it. And you're using what's called the zero product property. And basically all that says is if two things are multiplied together and they equal 0, then at least one of those two things had to have equaled 0. So you're multiplying together x plus 6 and x minus 4. If I took this guy and factored it, I'm multiplying those two factors together and I end up with a product of 0. That means that either x plus 6 has to equal 0 or x minus 4 has to equal 0. By setting them both equal to 0, I figure out that x equals negative 6 or x equals 4. These are the two x values, the two places where it crosses the x-axis for where y equals 0. Those are the solutions. Once you've done that, you're done. So an example, and this is a borrowing example, I had to borrow the 5. Then we see that the x plus 7x, or excuse me, x squared plus 7x minus 30 factors into x plus 10 and x minus 3. I've got to borrow back the 5, which I do, and then I get x plus 2 and 5x minus 3 equals 0. So when either one of those equals 0, then what I've got up here is I've got to set x plus 2 equal to 0, and I've got to set 5x minus 3 equal to 0. So x either equals negative 2, because I just subtracted 2, or I have to add the 3 and then divide by 5 and I get x equals 3/5. Alright, so this method simply is just adding one more step to the factoring you've already been doing. You just set each factor to equal to 0. That's the only other new step. Alright, method 2 is the square root method. So if the equation's in vertex form, or if there's no x term, then you can solve by taking the square root. So if it's in vertex form, you don't want to have to take it all the way to standard form just to factor it. So what I have here is an example. X squared minus 9 equals 0. Yes, you can say, is that a perfect square? Is that a perfect square? Is that a minus sign? And this could factor into x plus 3 and x minus 3. Yes, it can. But I could also just add 9 to either side. I get x squared equals 9. Then I can just take the square root to get rid of the squared, and I get x equals plus or minus 3. Now think about that. If I had x plus 3 and x minus 3, and I set each one of those equal to 0, I would get a positive 3 and a negative 3. So this one number with the sign in front of it represents two numbers, positive 3 and negative 3. It's important to remember those signs because these often do have two solutions. So an example like this where I get x squared plus 4 equals 0. Even though both of those are perfect squares, that's a plus sign. And you cannot factor that anyway. So I'm going to subtract 4 from both sides and I get x squared equals negative 4. When I take the square root of this to get rid of the squared, I get x equals plus or minus 2i, because square root of a negative makes it an i. So here comes the complex numbers back. Alright, so x equals plus or minus 2i. So this has two solutions, but they're not real solutions. Alright, one more example here. This one's something that's in vertex form. X plus 2 squared minus 16 equals 0. I add the 16 to both sides, and I've got x, well here I have x squared, x plus 2 squared equals 16. To get rid of that squared, I take the square root of both sides, and that takes me down to x plus 2 equals plus or minus 4. This is the part where people often mess up, because what this means is that x plus 2 equals 4, or x plus 2 equals negative 4. So when I solve this, I get x equals 2, When I solve this one, I get x equals negative 6. So you've got to make sure to set it equal to both the positive and the negative 4 when you're solving this way. Some people prefer the square root method to factoring. They can't stand factoring and don't want to do it. So if you like the square root method more than you like factoring, you can always put the equation from standard form into vertex form and then do the square root method. So this would be an equation. You could factor it, but if you don't want to factor it and you want to see it in vertex form first, we would do exactly what we were doing before. We were moving them from standard to vertex form. It's called completing the square. So we're going to put parentheses around the x squared minus 4x and leave your plus 3 out there. I'm going to do my shortcut and say, okay, x, and then half of this is negative 2. Negative 2 squared is 4, so 3 minus 4, right? And 3 minus 4 is 1, negative 1. So now I have the x minus 2 squared minus 1 equals 0, and I can use that square root method. So I'm going to add the 1 to both sides, take the square root of that, and I get x minus 2 equals plus or minus 1. So again, remember that tricky part. I've got to make sure that I make x minus 2 equal to the positive version of 1 and x minus 2 equal to the negative version of 1 because it's going to cross in 2 places. I'm going to add 2 to all 4 sides really. And so x is going to either equal 3 or x is going to equal 1. Alright, the last thing about in these notes is that you can solve a system of equations where one is quadratic and the other is linear. And it's as simple as actually just setting them equal to each other and solving. So when I have these two, if I said, okay, I want to solve these two and find out where does this line intersect this parabola. And I know that sounds really scary, but since both of these things equal y, I can set them equal to each other. So I've got this 3x squared plus 4x plus 20 on this side equals, because they're both equal to y, negative 2x minus 4. So in order to solve this, I need to get it equal to 0. So I'm going to get rid of my right-hand side by undoing those negatives and adding to both sides. So I get negative x squared plus 6x plus 24 equals 0. Now this is something where I can see there's a 3 in all 3 of these pieces, and I really want x to be by itself. So I'm going to undistribute or factor out the greatest common factor of negative 3. So the negative 3 comes out, making this a positive x squared. And then when positive 6 is divided by negative 3, I get negative 2x. And then when positive 24 is divided by negative 3, I get negative 8. So I get this trinomial equals 0 when it's being multiplied times negative 3. I can kind of just ignore the negative 3 at this point, because the negative 3 is not going to change the actual value of it. It stretches it, but it's not going to change where it crosses the x-axis. So I'm just going to factor out this guy, all right, the two numbers that multiply to give me negative 8 and add to give me negative 2 would be negative 4 and positive 2. I'm going to set each factor equal to 0. So x is going to either equal positive 4 or x has got to equal negative 2. These are the x values of the points where the line and parabola intersect each other. Okay? To find the exact points, if you're asked to do so, you just plug the x's that you got, those two different x's, into one of your two equations that you started with. I personally would plug it into the line because it seems simpler to do. So I'm going to plug in the 4 on this side, and I'm going to plug in the 2 over here, and I get negative 2 times 4 minus 4, and that ends up being negative 12. That's your y value, with your 4 as your x value. Then with an x value of negative 2, I plug that in and I get 0. So my 2 points where they intersect are at 4, negative 12, and at negative 2, 0.